All right, so let's talk about how to figure out what's going on with a particular atom, okay? So we're going to try to demystify protons, neutrons, and electrons. The first thing you need to understand is that the atomic number is the top number on the periodic table, and it's equal to the number of protons. So we can immediately go down and start filling in a lot of holes just based on that. Okay, so we've got 50 and 50. All right, and this said it was iron, so that means we can look at a periodic table. Okay, here's iron, and you see, periodic table, so 26, so we can go back and we can slop 26 on there. Okay, now the mass is the protons plus the neutrons, so protons plus neutrons. Okay, so here we have 26 and 30, so that'll give us the mass, so that'd be 56. 1 and 2, so that'd be 3. Okay, now if we know this, we also know that we can get neutrons by doing the mass number minus the proton number. Okay, so here we have mass of 24 minus 12, so that'd give us 12 neutrons. And let's see, we've got mass number of 57, 26 protons, so that'd give us 31 neutrons. And then we already know our neutrons down here. Okay, so we're getting there. Okay, now let's talk about charge. Charge is the balance between protons and electrons. So here I have 2 plus, so I have 2 more protons because protons are positive, electrons are negative. So I have 2 more protons than electrons, so 10 electrons. All right, here my charge is 0, so that means my protons and electrons are the same. Plus 3, that means I have 3 more protons than electrons, so 23. Here, charge of 0, so I should have the same number, 1 and 1. Again, charge of 0, so again, I should have the same number. Okay, all right, now the atomic number is also the number of protons, so that gets us these. All right, the isotope is actually the name of the element, so let's see, element 12, that would be magnesium. So we can go and we can write magnesium. We're just going to put Mg, and then it's dash the mass number. Okay, all right, 26, we said a while ago 26 was iron. So this one's iron, and mass is 56. That one's already filled in for us, iron 57. This is atomic number 1, that's going to be hydrogen. So hydrogen 3. And then element 50. Element 50 is Sn, which is 10. We'll just write Sn though. So we got Sn, 3 there. I don't know where it went. All right, Sn. And his, oh, we never filled in his mass. Look at us. Oh no, I didn't mean to do all that. Okay, so mass was protons plus neutrons, so we got 50 plus 72, that is 122. There we go. Now we can fill it in, 122. All right, and the nuclear symbol is going to be your symbol, and then mass goes on top, so 24 on top, and then atomics on bottom, so 12, and then charge is in the corner. All right, again, symbol, mass on top, atomic on bottom, and charge. You don't necessarily have to put the 0. All right, again, symbol, mass, atomic, and charge. And symbol, mass, atomic, charge, and the last one I'm going to write a little bit lower since I accidentally scratched across there. Mass, atomic, and charge. All right, the average atomic mass is the bottom number on the periodic table. So if we looked at magnesium, if you looked at your periodic table, magnesium would be 24.30. All right, iron would be 55.85. All right, same for here because this is also iron. And hydrogen would be 1.0079. All right, again, just the bottom number from the periodic table. And then 10 would be, I have to look for that one. See, it'd be 118.71. All right, now, isotopes. Isotopes are when you have the same number of protons, different number of neutrons. So on this table, I see two things right here that have the same number of protons, but different numbers of neutrons, which means they have a different mass. So 2 and 3, okay, so these ones, they are isotopes, okay, because they have the same number of protons, different number of neutrons, okay? All right, now if we were looking at the periodic table, we could tell just by looking at the average atomic mass which isotope should be the most abundant, okay? So what mass that isotope would have. So let's try phosphorus. Phosphorus has a mass of 30.974. So I would expect to see a lot of whatever that's closest to. So this is closest to the number 31. So I think there's the most phosphorus 31. Okay, and in fact there is. All right, let's try another one. How about, all right, radium. Radium is 226.02. So I say the most radium is 226, and in fact it is. Okay, so whatever that number rounds to, that's the mass of the isotope that's most abundant for that element.